Hello curious minds! Welcome back to our space lab.
Let's see how we can make a pulsating light. A microcontroller typically has power outputs in the range of 5 volt and 3 volt. Each of its ports are already programmed to supply either 3 volt or 5 volt. They cannot be interchanged. So how do we make an LED or a light pulsate? Pulse width modulation. Few of the ports on the microcontroller have these characteristics, and you can find them by finding the wavy arrow in front of the number allotted to them. In this case, we will be powering the LED from port 9. So what is pulse width modulation? Pulse width modulation is when the frequency of the voltage is switched in the seconds or in the microseconds. It is so fast that we cannot see this switching in the naked eye. But this can be seen as the dimming or the brightening of the LED. Let's see how to make the connection. For this, we would need the Arduino, a breadboard, resistor, an LED, and 5 wires. Connect the LED to 5E and 6E on the breadboard. Connect the red wire, which is the powering line, from the port 9 on the microcontroller to 6D on the breadboard. Connect a resistor on 5P and 3B on the breadboard. Connect a blue wire from 3A and connect the negative to the negative of the breadboard. Connect the black from the ground on the microcontroller to the negative on the breadboard. Let's see how the code is written.
As usually, we start with defining our variables. We've checked that pin 9 on our Arduino has a small wave sign, meaning it can be used for pulse width modulation. Let's name pin number 9 light in our code. Then we will also need to know how bright our light is and how fast it's fading. Every color in the digital world is composed of 3 basic colors: red, green and blue. Each of these colors is defined by 8 bits of information, which gives us 2 to the power of 8 combinations for each of the 3 colors. Only when all of 3 colors take the highest value, or 255, we'll have pure white color. If we do not take specific colors into consideration, but rather consider a black and white scheme, then 255 would mean completely bright and 0 would mean completely dark. We use brightness variable and set it to 0 first, which means it's absolutely dark when we start, or the light is turned off. For the speed of fading, we define a variable fade speed and set it to 5. Then we start setting up our program and assign the light pin to output, as usually with pin mode light output. Finally, we write our loop. Here we are using a new command, analog write light brightness. As you remember, we have only used digital write so far. With analog write, we activate pulse width modulation for the given pin and set it to brightness that we've defined before. That was 0 or completely dark. Then we wait 25 milliseconds with delay 25. Now we change our brightness level by adding fade speed to it. The brightness should be set to 0 plus 5, which equals 5. Now, as you can imagine, if the loop starts all over again, we'll give our light new brightness, then add up 5 more points and wait again. By and by, the light will get brighter and brighter. But it cannot last forever, right? What do you think is the highest possible brightness level that we can reach? Correct! As we have already discussed, it's 255. So whenever your brightness level reaches 255, you will want it to go backwards and start dimming with every step. That's why here we write an if statement. If brightness equals 255, then we reverse the speed of fading and make it negative. This is a simple if statement which changes the fade speed to negative the moment we reach brightness level 255. But what happens when after dimming the light many times again we will reach 0? Correct. We'll need to change the fade speed back to positive so that our light gets brighter with every step again. So we add to our if statement another condition. Now, fade speed reverses not only when we have reached 255, but also when we reach 0. Now, let's run it. See, our light is getting darker and then it's getting bright again. Try it on your own and tell us in the comments how it went. Stay tuned for more exciting Arduino videos. See you in the next video!